Hey y'all, it's Miss Johnson. Back at it again. Today, the assignment for the asynchronous class is turning equations into graphs and tables, and turning tables into equations for exponential functions, right? As we talked about in class, and as is on the notes for class today, an exponential equation looks like a number times another number to the power of x, right? And we're going to talk about how to read those and turn them into graphs and tables, as well as make them from a table. Let's get to it. We're actually going to start with the one we did in class, tables to equations, and that's the second part of your worksheet, but here we are. The two things we need for our equation is our starting number. This is the, we'll call it the y value when x is equal to 0, and we refer to it as a starting value, starting point. Right, and then this other number is the number you're multiplying by. When we're trying to find the next thing in our equation. Let's do two examples. So if here's my partially finished table, the instructions for this section are to finish the table, just like we did in class, and to write an equation, again, just like we did in class. The first thing we're going to do is, when we move from 36 to 108, what are we multiplying by? The way we find that out is we do 108 divided by 36. And you can do this on a calculator or on Google or whatever, and we get 3. And that means our B term is 3. To fill in the rest of the equations, or fill in the rest of the table, we're going to do the inverse of multiplying by 3. We're going to divide by 3 to go backwards. 36 divided by 3 is 12, and 12 divided by 3 is 4. And the reason we wanted to fill this in is because we need to know what's the y value when x equals 0 to act as our starting point. And now we've filled in our table, we've done our equation, we're finished with this problem. Let's try another. Here, same thing. We need to know what did we multiply by in order to get our next number. Negative 50 divided by negative 10 is 5. So we can multiply by 5 to get our next number. We can divide by 5 to get our first number. And now we can go ahead and fill in our equation. Our starting number, our y-intercept, right, is negative 2. And then our the number we're multiplying by is 5. We're allowed to have negatives. That's just how it is. Here we are. If for some reason our number we're multiplying by was negative, like if our table looked like this, 0, 3, 1, negative 21, 2, positive 63, whatever, right? If this number was a negative number, it's super allowed to be, right? That's not a problem. We just need to put parentheses around the negative part to make sure this x is going to all of negative 7, not just the 7 part. Cool. So again, that is tables to equations. We can also call this the y-intercept, because that's what it is. All right. Now let's go from equations to tables and graphs. We just said that this was the starting point. This is when x equals 0, right? When x equals 0, we also call it the y-intercept, intercept. So the first thing we're going to do is put in x equals 0, y equals 3 for this equation. We just get it for free. We're not doing any math. We're not doing any computational math. We're doing interpretation math when we're filling that in. And then for the table, the next thing we know is that we multiply by 2 when we go up by 1. So we just fill in 0, 1, 2, 3 on the x side. Right, we just add 1 every time, no problem. And on this side, we're going to multiply by 2. because that's what our equation says is the thing to do. So 3 times 2 is 6, is 12, is 24. And now when we go ahead and fill these in, I'm going to make this 1, 2, 3. Sorry, let me get close to this. I'm blind. 2, 4, 6, 8, 10, 2, 4, 6, 8, 20. Fine. So we say 0, 3, 1, 6. This one's 12, and this one's like 24. When we connect the dots, we start to get this. It's not a straight line. It almost looks like this. Like it curves up and gets fast. Like gets tall really fast. Awesome. The other way we could do this, instead of making a table and just like being on this side, we can actually just plug in like, we can plug in a 1 here. We can plug in a 2 here. We can plug in a 3 here, right? So for x equals 1, we have this. For x equals 2, we would plug in a 2. For x equals 3, we can think of this as plugging in a 3. We plug in a 1, this is just 3 times 2, which is 6. Nice. This is 3 times 4, which is 12. This is PEMDAS when we're simplifying this. So we do the 2 squared first is 4, then 3 times 4 is 12. And then again, for plugging in 3, we'd say 2 to the third is 8. And then 3 times 8 is 24. And that's another way to get these numbers. Is actually just plugging in to your original equation. Let's try one more, and then I'll let you loose, and you can do it yourself. Let me move this down. There we go. Great. Let's do orange. So for this one, we're going to start with 0, 1.5. Then we're going to write this down to 3. And then I'm going to say each of these we multiply by 4. Or we plug in each of these numbers as the actual exponent, right? X equals 3 would have been 1.5 times 4 cubed. I'm going to do the table version. So I'm going to type in 1.5 times 4 in my calculator and get 6. 6 times 4 is 24. And then 24 times 4 is 96. Right? Again, if we had plugged these into our calculator, or if we had done 1.5 times 16, and then 1.5 times 64 is 96. When we're graphing these, I'm going to make the x and y axis kind of wonky, right? The x and y axis, you can tell like this one goes up by 1, so it goes from 0 to 3, and this one's 1.5 to 96. So we're either going to need to like do a lot of more tick marks on the top, or we're going to have to stretch this one out. So I'm going to make the top here 100, and then I'm going to go 2, 4, 6, 8, 10. I'll make this 50. 5, 1, 2, 3, 4, 5. That'll be 75 and 25, just so I know that I can get all of these numbers on my y-axis. And then I spread out the 1, 2, and 3 because there's just not that many numbers down there. And now we say 0 is 1.5. That's like way down here. 1 is 6. That's like here. 2 is 24. That's like almost at 25. And 3 is all the way up to 96. An exciting part of exponential functions is that they grow really fast, right? It's like they do not waste time getting big. It kind of shoots off. All right, y'all, that's basically what the worksheet is today, the assignment for this afternoon. If you have any questions, message me over Teams today, or come talk to me on Tuesday or Wednesday office hours before class on Thursday. All right, thanks for working hard. I'll see y'all later. Bye.